Hi everyone. In this video I will be demonstrating multiple regression using dummy coding of a multi-categorical predictor in Stata. And before I get started, I do want to mention that underneath the video description you will find a link to a Stata data file that I've put together, so you can actually download a copy of that data file to follow along in the video presentation. Additionally, under the video description you will find a link to a PowerPoint, and basically that PowerPoint is going to contain a lot more detailed information with respect to the output that I'm going to be covering in this video. So the video portion of this presentation is mainly focused on giving you the how-tos, how to generate the output associated with different examples that are given in the PowerPoint, and then the PowerPoint is really designed to kind of give you a deeper dive when it comes to understanding the meaning of various outputs. So just kind of keep that in mind. So that I do strongly encourage you to download a copy of the PowerPoint if you are not familiar with interpretation of multiple regression results, particularly in the context of dummy coding. So the example that we're going to be working from in this video is based off of one from Darlington and Hayes 2017 book, Regression Analysis and Linear Models, Concepts, Applications, and Implementation. And so you will see on your screen right here, the data set is actually fairly small, and we have several variables that are included. And what we're going to be doing basically is regressing life satisfaction. That's going to be our dependent variable onto a measure of marital status, and then later on in the presentation on income as well. So the first few examples we're going to be regressing life satisfaction onto marital status, and then later on we'll regress life satisfaction onto marital status and income. So the first few demonstrations are akin to running an analysis of variance, or a one-way analysis of variance through linear regression. Okay, so before opening up Stata, let's talk a little bit about our first model that we're going to be running, and basically the variables that will be included. So here you can see where I'm laying out a dummy coding system for the marital status variable. So the basic idea is that if you have a factor variable and you want to include it in your regression analysis, you're not going to want to do that directly, like as in the case of our marital status variable, where actually it's a nominal variable. But what we want to do is to recode that variable into a new set of variables that contain the same grouping information but is amenable to inclusion in a regression analysis. So as you can see right here, I've got marital status. This is the original variable right here, and then I have three dummy variables that I have created. So basically the number of dummy variables that you will include in your regression analysis is going to be equal to the number of groups associated with the original variable minus 1. So because marital status has 4 levels, we have married, divorced, single, and widowed. That means that we want to create 3 dummy variables that contain the grouping information. Now, another decision that you have to make when you're creating your dummy variables is a decision regarding a reference category or a baseline category. So in other words, what we're going to be doing is we're going to be creating a system such that the regression coefficient reflect differences between each of the groups on marital status and a baseline group or a reference category. So for this first demonstration, what we're going to do is we are going to set up the widowed group right here, that's group 4, as our baseline category. And this is just an arbitrary decision on my part. And I'm going to show you a few other examples where we kind of change up the reference category, just so you can see that it is ultimately an arbitrary issue or an arbitrary decision in this particular case. But you know, when you're running your data analysis, you might have some logical reason why you might choose one group as a reference category. So right here you'll see that with dummy variable 1, what I've done is I've set up the codes of 1, 0, 0, and 0. Okay, so by virtue of this, essentially we are establishing that variable 1 is kind of reflecting kind of the married category. And so the regression coefficient is essentially, when we run our analysis, it's going to be a comparison of individuals who are married and those who are widowed. And you're going to see with the D2, or the divorced variable right here, in this case, I've set up a 1 for the divorced group and zeros for all of the other categories. So the regression slope for the D2, or divorced dummy variable, is going to reflect the difference between individuals who are divorced and those who are widowed. Then for D3, I've got a 1 set up for the single category, when zeros for the other groups. And so in this case, what this is going to mean is that the regression coefficient is going to reflect a comparison between individuals who are single and those who are widowed. Now you might be asking, where is that fourth dummy variable? And as I said before, we're going to use J-1 dummy or indicator variables, basically the number of categories from our original factor variable minus 1. And the reason why is because we actually have all of the grouping information for our original categories contained within these three dummy variables. If you'll notice that individuals in the married category, they're coded 1, 0, and 0 across the three dummy variables. Individuals in category 2, the divorce category, are coded 0, 1, and 0. For those in the single category, they're coded 0, 0, and 1. And then for the widowed category, they are coded 0, 0, and 0. And if we tried to add in a fourth dummy variable for widowed, where we had 1 for widowed and zeros for all the other categories, we would end up with a problem of collinearity, and basically it would create problems with running our analysis. So we don't want that to happen. So that's basically what we're going to start off with in terms of our example. So there are a couple of ways. I've already opened up Stata right here, and so there are a couple of ways that that we can generate the results for this first analysis. One way is to use a drop-down menu system. If you go to statistics here and then go down to linear models and related and to linear regression, we can specify our model very easily. Another option is to use the command line. So I'm going to start off with just kind of using this drop-down menu right here. So again, we go to statistics, linear models, and related, and we'll click on linear regression. And I've actually already kind of specified the model, so I'm just going to kind of clear this out just so you can see what's going on. So remember that our variables, I've already imported the data. These are the variables in our data set over here. And so when I've gone through and selected linear regression right here, the dependent variable, I'm going to put that in. So that's life satisfaction right here. For the independent variables, we're going to be selecting marital status. Now, because this variable is a factor variable, one thing that we can do is we can add, or we need to add, a prefix. So the prefix, for a standard analysis would be an I dot. Now, if I do this, what that's actually going to do when I run the analysis is it's going to treat the first category as my reference category, and it happens to be the case that our first category on our original variable is married. And remember, we want to set this up for the reference category being widowed. But if I click on OK right here, you can just kind of see what happens. You'll see that it basically has created our several dummy variables for us, and you'll notice that we've got divorced right here, there's single, and there's widowed. And you'll notice there's no dummy variable in this case for married, and the reason why was because when I use that I prefix right here, it's going to default, or I dot prefix, it's going to default by giving me the first or treating the first group on my factor variable as the reference category. So if I want to change that, I can do that very easily. And remember, again, for this first demonstration, we are going to be using the widowed category as our reference category. So I can do that. I can change that very easily. I'm just going to go back in here, and instead of using the I, I'm going to type in B and then 4. And remember, basically the original variable was coded 1 for married, 2 for divorced, 3 for single, and 4 for widowed. So if I type in the prefix B4 right here, dot, marital status, when I click on OK, you'll see now widowed is being treated as the reference category. So you'll see we've got married, a dummy variable for married, a dummy variable for divorced, a dummy variable for single right here. Now when you look at the intercept that's given right here, and I do talk about this in the PowerPoint I was referencing, the intercept in this current case is going to equal the mean of the widowed category. And each of these coefficients right here, these regression coefficients, are the differences between each of these categories and the widowed category. And so really, because all of these values are positive, it's telling you that the life satisfaction for people who are married, divorced, and single is actually higher than that for individuals who are widowed. Now you can also see that we have significance test results. So you've got these coefficients here. These are just differences in means. Our standard errors, t-values, and p-values. So basically these are all t-tests that are being carried out. So you can see that the comparison, or the difference between individuals who are married and individuals who are widowed, that difference would be deemed as statistically significant. Between divorced and widowed, that difference at the conventional 0.05 level would not be statistically significant. The difference between individuals who are single and widowed, that difference would be deemed as statistically significant. Okay, and if you look up here, you'll see that we have the R-square value, which is 0.4214. Sorry about writing over that. That's just basically indicating that marital status is accounting for about 42% of the variation in life satisfaction. And then we have this F-test right here. And so this is an omnibus test of the effect of marital status on life satisfaction. You can see that the FA is 3.88. The p-value is 0.0292, indicating statistical significance. Basically, as I had mentioned earlier, this is analogous to running a one-way ANOVA. And just to show you as a point of comparison, let's generate some ANOVA results. So what I'm going to do is I'm going to type in ANOVA in the command line, follow that by LifeSat for life satisfaction, and then I'll type in marital status right here, and then hit enter. And as you're looking at this, you're going to see that the R-square value that's given right here, the 0.4214, that's literally the same as what we have up here. There's our adjusted R-square too, if you want that. The F value is 3.88. So you can see right here the model F, or if we want to just look at the independent variable right there, it's 3.88. And then the p-value is 0.0292, exactly the same as what we had up here. So that's essentially what we've done, is we've run a one-way ANOVA by way of regression. Okay, so in the PowerPoint, I started off with the first demonstration where I am illustrating the regression with the widowed category as a reference category. In example 2, I actually demonstrate the analysis with the married category as the reference group. And we actually started off with that where I was kind of showing you how to kind of use that little B prefix and I prefix. Just really briefly though, I'll kind of re-demonstrate how to generate the regression results with the married category as the reference category. So as you guys hopefully remember, if we go up to statistics here and go back to linear regression, if I just set this as I dot, that's going to treat the married category as the first as a reference category. Or if I had wanted to, I could use B1 dot marital status, and that would do exactly the same thing. So there you go right there. Now at this point, I want to highlight that when you run your analysis through these menu systems, the nice thing is that it does generate the syntax that you would ordinarily use to run the analysis. So you can see right here it says regress space, then it's got the name of the dependent variable, and then it's got the name of our independent variable with that little prefix right there. So I could run this straight from the command line very easily just by typing in regress lifesat b1 dot marital status. That's the whole name for the variable there, and we get exactly the same results. So briefly, just kind of I want to note that the overall model fit is going to be exactly the same as what we had generated previously when widowed was the reference category. So the overall fit of the model is exactly the same. The only difference that we're going to see right here is it concerns our coefficients and our tests, because in this case with our coefficients, first off, our intercept is the expected mean for the married group. So just keep in mind that the intercept in the context of multiple regression is going to equal the predicted or expected value of the dependent variable when all of your predictors are equal to 0. So because marital status, if we treat that group, treat married as a reference category in our analysis, that variable through a dummy coding system is coded 0 on all dummy variables. So because of that, then the intercept is going to equal the mean for the married group. And so all of these coefficients that you see right here, these are differences between individuals who are divorced and married. So you can see like this negative slope right here, this negative 6.3 indicates that individuals who are divorced, their mean level of life satisfaction is 6.3 points lower than individuals who are married. And that difference, though, is not statistically significant. If we look at single right here, we have a negative 3.1, and basically that's indicating that individuals who are single are scoring on average about 3.1 points lower than individuals who are married. That difference is not significant. But then when we look at widowed, you can see a minus 14 right here, and that's indicating that those persons who are widowed are scoring approximately 14 points lower on average than individuals who are married, and that difference is statistically significant at the conventional 0.05 level. Okay, so example 3 in the PowerPoint basically involved treating the single group as a reference category. So I'll just quickly generate those results and then we'll move on. So to do that, we'll type in regress lifesat right here. That group is group 3, so I'm going to type in B3 dot marital status, which is the name of our variable, and yeah, as you can see, I just kind of incorrectly spelled it. So let's try that again. We'll type in regress lifesat B3 dot marital status and enter, and so now you can see that the single category is not given, but you can see that we have the remaining categories that are given in our output. Okay, so examples 4 and 5 in the PowerPoint basically involve treating the divorce category as a reference category. Example 4 is basically the same analysis, but again treating divorce as a reference category. Example 5 incorporates the added predictor of income. So just really quickly, I'm going to generate both sets of results. So for example 4, we'll type in regress lifesat. We'll type in B2 dot marital status, and there you go. And so you can see right here that divorce does not show up in our output under the marital status variable. We have married, we have single, and we have widowed right here. Now if we want to add in our covariate, it's very easy to do. Again, we'll just type in regress lifesat B2 marital status and income and hit enter, and so now we have our analysis with the income variable included. So now as we are looking at our output, you'll see the R-square value is up to 0.7676, so roughly we're accounting for about 77% of the variation with marital status and income incorporated into our same model. You can see the overall fit. We have basically the set of predictors are accounting for significant variation in life satisfaction. As you're looking at the intercept here, again, keep in mind that the intercept is the predicted value on y, our dependent variable, when all of our predictors are equal to 0. So recall that with respect to our dummy variable, basically the intercept is going to equal the mean for individuals who are both of 0 income and divorced. Now that doesn't make a whole lot of sense if you say 0 income, but perhaps it is possible. So that could actually make some sense. But if nobody in your data set had actually 0 income, then you might want to do something like mean center your income variable before you run your analysis. But nevertheless, we can say that looking at our intercept, again, this would be equivalent to the mean life satisfaction score for a person who is divorced and with 0 income. And then we have the remaining regression slopes right here for our dummy variables. So these are basically adjusted for the income variable that's been included in our model. So these are still comparisons in terms of the means between married and divorced right here for this one, single and divorced right here, and then widowed and divorced right here. So all of these coefficients are reflecting differences in adjusted means, again adjusted for the presence of the income predictor. But when we look over here at the significance test, none of those differences are significant at the conventional 0.05 level. But when we look at the income predictor right here, it's positive, indicating that individuals scoring higher with a higher income tended to report greater levels of life satisfaction. You can see that that predictor actually is significant in our model. Now, at this point, you may be asking yourself, well, or thinking to yourself, I don't necessarily want to look at the comparisons in this kind of way. I want to look at the overall effect of marital status in addition to income as predictors. So I want to look to see if marital status has any unique contribution to life satisfaction. And so when we're looking at our model in this kind of way, where we've broken out the effect of marital status across these dummy variables, then we're not really able to look at the overall effect of marital status. So one thing that we can do is we can use our ANOVA function again, and in this case I'm just going to quickly run an ANCOVA just to kind of get a quick test of the overall effect. So if I type in ANOVA, and then we'll type in life sat for our dependent variable, I'll type in marital status, and then we'll type in income, but I need to indicate that that income variable is a continuous variable. So I'm going to type in a C dot income. So we've prefixed income with a C to indicate that it's a continuous variable. And when I press enter, now I have a test of the marital status variable. And so as you can see right here in our, this is basically an ANCOVA that I've run. And so as you can see right here for marital status, the F value that's given is 4.24, and there's our P value of 0.0234 right there. Now, if you look too at the income, this is basically the covariate within our model. The F value that's given right here, you'll see that, well, you don't really see that 22.35 in our output, our regression output, but basically the 22.35 is nothing more than the square of the t value that's given for our regression coefficient, for our test of the regression coefficient in our output. So just to show you what I'm talking about, I've just kind of called up a little calculator right here. I'm going to type in 22.35 from the ANOVA table for that F value. So I'll type in 22.35, and I'll take the square root of that, and you'll see it says 4.27 right there, roughly 4.73, which you see up here in our output. So there it is right there for that t value. Now at this point I will say too that there is another way to test out the omnibus effect of our marital status variable and also obtain an R-square value, or basically a squared, or rather a multiple squared semi-partial correlation for marital status, and that's basically using a package called HiReg. So to utilize the package, first off we need to make sure that that package is installed. So what I'm going to do is I'm going to go to the command line right here. I'm going to type in down here find HiReg, H-I-R-E-G, and then actually there was a little error there. My apologies there. I'm going to type in find it HiReg. So we're using the find it command, and so there's a package at this link right here. If I click on it, I've actually already installed it, but I'll just quickly install it again or reinstall. You can see it just says all files already exist and are up to date. So I can use a HiReg command in order to generate essentially results from a hierarchical regression, one that basically just contains the income variable, and then a second one that contains both income and marital status. And so the change in R-square would reflect the added contribution of marital status, and so that can kind of serve as an effect size measure, and then the test of the change in R-square would be producing a test of the effect of marital status. So at any rate, if I go back down to command line, one thing that I do need to do in this case is I cannot use marital status as a factor variable with this particular package. So unfortunately what I'm going to have to do first is to create the dummy variables manually. So to accomplish that, I'm going to go down to the command line and I'm going to type in tabulate. So we're using the tabulate command, marital status, then we're going to type in comma and then gen or generate, and then follow that up with marital CAT. I'm just basically creating a new name, if you will, associated with a set of dummy variables. You can kind of think about that marital cat as a root name, if you will. So I'll hit enter right here, and so you can see that in my output I've got frequency counts associated with each of those categories. So I've got married, frequency count of 6, divorced 5, and so forth. And if I open up the data editor, you can see right here that it's created a set of 4 dummy variables. But remember, when we run our regression analyses, we're only going to be using 3 at a time. But nevertheless, it's converted the information from our original variables into 4 dummy variables with a root name, marital cat, and then we have 1, 2, 3, and 4 signifying individual. Marital cat 1 is for married, marital cat 2 is for divorce, marital cat 3 is for single, marital cat 4 is for widowed. And all that information is kind of being demonstrated right here. Now at this point I might also want to kind of rename these so that my output has a little bit more meaningful names, because right now if I run a regression analysis, then I'm only going to see marital cat 1, marital cat 2, marital cat 3, or marital cat 4. So if I go down to my command line, I'm going to use the rename function as well, and I'll type in marital cat 1 space, and then I'm going to type in married. Okay, so when I hit enter, now it's renamed the original, that first marital cat 1 to married, so that now it's going to look a little bit more intuitive when I start running my analysis. I'll do the same thing for the others, so we'll type in rename marital cat 2, and then this one will be divorced, rename. Okay, so sorry, I just kind of stopped that for a second so we wouldn't spend all our time watching me type. So now you can see I've used the rename function. I've renamed the marital cat 1, 2, 3, and 4 to married, divorced, single, and widowed. And all those variables are showing up right here on our screen. So now we can use the HiReg command. So I'm going to type in HiReg, and then the name of the dependent variable, which is life set again. So, and then inside parentheses we're going to have 2 sets of parentheses with variables included in them, reflecting independent variables that are being added over a sequence of models. So the first block is really just going to incorporate the income variable. So I'm going to type in LifeSat income, and then we'll have our next parenthesis, and I'm going to type in the names of our dummy variables, and we're only going to include again 3 of them. And just to keep it consistent with our previous model, we're just going to use married, single, and widowed, leaving the divorced category as our reference category. So I'll press enter, and so now we have our output. So you'll notice first off we've got model 1 right here, and model 1 only contains the income predictor, as you can see. Then we have model 2, and we've added in married, single, and widowed. Okay, so we've added in that compositional variable, if you will, and so then we got our output associated with it. And then when we scroll down, you'll notice that we have the R-square values and R-square difference, R-square change. So you can see right here we've got model 1, the R-square values, there's our f-test again, our p-value. Then we've got model 2 that's given with the R-square value for that particular model. And the f-test. So all those results are the same for model 2. That's the same as what we have given up here. And then we've got the R-square change. So the change from model 1 to model 2 is 0.197. So in other words, by virtue of adding in the marital status variable, we are accounting for an additional almost 20% of the variation in our life satisfaction variable. And so that change, as you can see with our f-test and our p-value that's given, is statistically significant. And these values that you see right here, these are the same values that we saw earlier in our ANCOVA table. If I go back up to where we had generated that before, you can see we have the 4.24 for the f value and 0.0234 for the p value. If we scroll back down, once again, there's the 4.24 and the 0.02. So that's exactly the same. So that now we have an effect size measure associated with our compositional variable, our factor variable, and the significance level for that variable. Okay, for the last demonstration, basically example 7 in the PowerPoint, what I was basically trying to do was to demonstrate how you can incorporate a mean-centered predictor or independent variable in the model. So, and as I mentioned before, the reason why is this can facilitate better interpretation of or more meaningful interpretation of the intercept. So recall, the intercept is the predicted value on the dependent variable when all of your predictors are 0. So if you happen to have a predictor where 0 is not within the observed range of values, or the range of values that are observed in your data, or perhaps not theoretically meaningful, then then it kind of renders that interpretation of the intercept a little bit more dubious. So what I want to do in this case is just incorporate a mean-centered income variable in our model. So to do this, what we're going to have to do is actually mean center that particular variable. So for starters, what we need to do is to generate the mean on that variable, and then utilize the generate command to create a new variable that is a mean-centered version of income. So what I'll do at this point is I'm going to type in sum or summarize, and then we'll type in, following that we'll have a space and we'll type in income. And so when I hit enter, you'll see that now we've got some descriptive information on the income variable, and there's our mean right here. So now what I want to do is to generate the mean-centered variable. So I'm going to type in GEN, or I could type in generate if I want to, and then the name of the new centered variable. So I'm going to type in income, CENT. That's just my naming system. It's nothing special about it. I'm going to type in equals, and then I'll type in income, and I can either type in the 56.9, or if you want to, you can kind of type in the excuse me, I need to type in income minus, and then I can type in R and then mean right here. This is just basically an R class object that gets kind of created as a little container that contains the mean right there. So at this point I've just typed in, once again, gen then income sent, that's the name that I've given this newly centered variable once it's generated, equals income minus R, and then inside parenthesis mean, or if I just wanted to type in income minus 56.9, I could do that. So I'll hit enter, and just so you know that, or so you can see it, this is the new variable that's been generated right here. If we go up and we look at our data set right here, that you can see it's shown there. So there you go. So now I'm going to go ahead and generate my regression results. So I'll type in regress LifeSat again, and then we'll type in income sent, which is the new variable, along with the B2.marital status. So you can see right here that I'm not going back to those dummy variables that we created manually. I'm just going back to the earlier models that we ran, just including the income, the centered income variable, and then we hit enter. And so now when we look at our output, you can see that here's our intercept, and so at this point, what we can say is that this would be the predicted mean on life satisfaction for a person who is divorced but falling at the mean of the income variable. And you can see that the regression slope for the income sent variable is exactly the same as what we had previously when we were using the uncentered variable. And the regression slopes and their tests, these are all exactly the same as what we had before, again, when we were using the uncentered income variable. Okay, so that pretty well wraps up this video demonstration. Again, I encourage you to check out the PowerPoint. As I said before, it goes into a lot more detail in terms of interpretation than what I've provided in this video presentation. Thank you all for watching, and I hope you have a great day.